Okay. Kung doon na kay structure yung ay, maduni mo ang depleted structure. Kita ninyo? Wala.
Makita sir.
So maduling na to, ma-estimate ninyo ang depleted structure ani. Butan na to, maduling ninyo. So ako doing ha. So ang beam mo ani siya. So this is the exaggerated bended form of the building. Kita ninyo?
Yes sir.
Okay. So kung doon na kay ingon ani nga beam, makuha ninyo ang depleted structure?
Yes sir.
So dili na ko pana. So that means nga ang iyang structure nga ang iyang reinforcement kinahanglan na is at the top. Yeah, kung doing na ko ang section kita ninyo?
Yes, sir.
Asa man ang reinforcement gibutang?
Sa
Why we need the reinforcement at the top?
Kaya ito man ang tension, sir.
Okay, that's correct. Because dinhi ang tension. Tension, compression. Okay. This is what we call the singly reinforced beam, no? So, kung kabalo ka mo evaluate og singly reinforced beam, dako na kay nakatabang sa reinforced concrete beam. Okay? But it doesn't mean nga ang tension weak, ang concrete weak sa tension na sa dimong reinforced. Pwede sad nimo i-reinforce ang compression para musamot pagyud kaligton. Okay? Musamot pagyud siya kaligton. So that is why there is what we call doubly reinforced concrete beam. So kung imo siyang reinforce sa compression, even though strong ang concrete sa compression, musamot ang iyang kalig-on. That's why some designer will design it as doubly reinforced concrete beam para ma-optimize nila ang capacity sa section by just some reinforcement on the compression side. But normally, the compression side has only minimal reinforcement, no? Minimal reinforcement. Okay, kasi minimal. Okay. So, mao na ang diferensya sa singly o doubly. Ang singly is for the tension only. Ang doubly reinforced is tension as well as compression. But always put this in your mind that the main reinforcement is always on the tension side. Ayaw gyud ninyo baliya. So when you are inspecting for rebar, for example, owners will call your attention to inspect the rebars before it is being covered by concrete, no? So reinforcement is already there. So always look on the tension side kung properly reinforced ba siya, no? Properly reinforced ba siya. So kung nabali ang reinforcement as daghang kay cases, no, ang tension side untaan reinforced because lack of knowledge or maybe lack of conveyance of the knowledge because lahi man gud ang magtrabaho sa field dili man engineer. So may tawag sa magtrabaho sa field. Kasi tawag sa may tawag nimo sa nagtrabaho sa building.
Foreman, sir?
Oh, naay foreman. Ang uban walay foreman. Unsa may naa didto? Pagyud, mismatch pagyud, panday, no? Panday mo nagkabilya. Di mga stillman, kasi mga building, no? Kanang kwan. Pataka lang sila ng butang og kabilya. Abi nila nga ang reinforcement ibutang lang sa simento, mauna na siya. So say mabali. Ang ilang gi-reinforce ang compression side niya, wala nung lang gi-reinforce ang tension side. So that is kwan. Type na siya. So sa term na reinforced concrete, the main reinforcement is located in the tension side. Mao gina siya pinakakuan. So always look for the tension side. Okay. Now, there is a need to inspect the building before pouring because the workers are not engineers. They do not know. They just follow what is in the drawing. Unya kinsay nag-drawing, usahay dili engineer, draftsman. So, supposedly kung draftsman mag-draw, i-approve pa dahil na sa engineer nga sakto ba pagkabutang ang reinforcement. So, kung wala na yung approval, dito na dayon, that means nga ang draftsman mo i-designer, no, dili engineer, kasi siya may nag-drawing. Nya, gihatag din dito sa field, gitabaho po dayon sa mga foreman which has no knowledge about reinforcement. So, ilalagi palo ang nasa drawing. So, kung panalitan sayop ang gidrawing sa draftsman, sayop ang nabutang sa field. Kunya kung gibuhusan dito, that means nga sayop ang kabilyada. That's why engineer is very important in the field. There should be a project engineer. Dili project engineer nga tuwa sa layo kayo, no, wala siya ato building, wala siya ni ato site, yung site to ato sa bukid. Nagbuhat og tulay dito, nakabilyahan na. Inulan niya. So without inspecting, so that's very actually dangerous to do, no? Why? Because you do not know whether the tension sides are well reinforced because they are the one that is needed. Okay. Although you need reinforcement on most concrete area for crack control, but crack will only happen if there is tension. Kung compression, minus ang cracking. Okay. So again, why we come up to this topic about bending, it's because of the topic where to put the reinforcement. Second is the difference between singly and doubly reinforced beam. Singly reinforced beam refers to the reinforcement put on the tension side, while doubly reinforced concrete is referred to section which has main reinforcement on the tension side and some reinforcement on the compression side. Tension side is not always at the bottom. It is also at the top, especially in the cantilever beam. Okay, on the cantilever, and even if the beam is fixed on the other on both sides, the near support moment gives you a parabolic curve that is facing downward. So that means that the tension is on the top, not at the bottom. So if you have a beam like this, I will do again. Okay, if you have a beam supported like this, okay, so if there is a load, W, kita ninyo class ng beam?
Yes, sir.
Fixed on both ends, right? This is not a simply supported. Okay, yes. So ang end depicted structure is like this. Okay. Mutuo mo yan ang depicted structure niya.
Yes, sir.
Okay, so if I'm going to put a reinforcement on this kind of beam, I put a reinforcement here. Why? Because the area with the reinforcement are what we call the tension side. Do you agree?
Yes, sir.
Okay, that is it. I am going to do a section here near the support. So if I'm going to do a section near the support named as EA, this is the section EA. Can you see? In section EA, the reinforcement is at the top. Okay? The main reinforcement. So there is no reinforcement at the bottom. Why? Because if you refer to the curve, it's compression at the bottom. And if I'm going to do the bending moment of that, ang bending moment ana niya, ingon ani. Ay, nabaliktad dito na ako pag-doing. No? So, ang bending moment niya, ingon ani ang bending moment niya. Okay, this is the bending moment. Ina mo na ang bending moment. Nahiway ang bending moment kung simply supported, wala yung negative moment. So, if I am going to do the section BB, so I have there another section. In the middle, this is the section. Do you agree?
Yes, sir.
Yes, sir.
Okay, we need the reinforcement at the bottom because it's the bottom that is tension. This is for a singly reinforced. Pero kung doubly reinforced, pwede nyo butang ang taas o kuan. Taas o ubos. And again, it's very important nga nung butangan na to ang taas o ubos. Okay. Taas o ubos. Okay, so kung doon na simply supported, so natural nga, the tension reinforcement is located at the bottom, right? Kita ninyo?
Yes, sir. Yes, sir.
Okay. Again, nga ulit kinalantag bottom reinforcement?
Kaya nasa ubos ang tension, sir.
Correct answer. Now, kung doble, bisan og ang compression side, butangan gyapon nimo, no? Butangan nimo. But not as much as the tension. Okay. Now, in practical, ngunanin ni sa actual, practical. Mao na siya inyo makita sa actual. Dili na siya lingin nga isa. Duha na siya at least at corner. Okay? Namoy nakita ang kalainan pag yun. Kung saan yung na-observe? Kung saan yung na-observe?
Naka-ring siya, sir.
Oh, correct. Na ring. Okay, gawas nga. How about the amount of reinforcement at the top and the bottom? Can you notice?
Mas daghan sa ubos, sir, kasi sa taas.
Again, because that is?
Kaya nasa ubos ang tension.
Oh, that's correct. And tension is not always at the bottom, ha? There are part of the structure It depends on the location. Ha? So, again, doon ay provision sa ring. Ang tawag aning ring is what we call, kung gamito na to ang generic na term, that is shear reinforcement. Mao na siyang itawag og shear reinforcement. Okay? Now, akong ipakita sa inyo ang ano kinahanglan ang shear reinforcement. Ako ipakita sa inyo ang anong kinahanglan ng shear reinforcement. So, we have a beam. Nasa load. Na shear reinforcement. Okay? So, kataas, simply supported beam. Okay? Doon ay reinforcement sa top, tapos ay gitawag na reinforcement sa bottom. Ang bottom man na niya, the main reinforcement. Ang taas, compressive reinforcement. So, this is a doubly reinforced concrete beam. Now, ang section niya na, magmula niya ang section. Doon ko na po din yung section. Okay? This is the section. Makita ninyo nga na bottom o top reinforcement. At the same time, doon na pag-i-ring. No? Pwede rin nyo natawag nga ring. Pero sa mga engineer nga inyong mga istorya, tawag yun ninyo na siya o shear reinforcement. Kung ano yung pinaka-generic niya nga name. No? Or tawag nyo stirrups. No? Stirrups. Kanang stirrup o ties, pareha na siya, pero ang ties, gagamitin lang ang ties kung kulom. Kaya ang kulom namya po yung ring. Ties ang ngalan niya na, tie. T-I-E. Yeah, kahit plural man, butangan mo is ties. Pero kung sa beam, tawag na siya stirrup. S-T-I-R-R-U-P. With S, stirrups. Pero ang common na niya nga name is shear reinforcement. Why we need the shear reinforcement? So, take a note. Doon na kay beam nga na i-load. Unsa may naa sa ubos? May makita mo sa ubos. Kasi nakita niyo sa ubos? Na-diagram sa ubos niya, unsa man na?
Moment, sir.
Shear of
End moment, sir.
moment. So, ang kining longitudinal reinforcement, kining main reinforcement, ang iyang isuportahan na moment ra. Kunya, tanaw ni mong taas, doon na may shear. So, wala para siya shear. Kung wala shear, mahitabo, muning mahitabo sa beam. Babalik lang siya agas sa shear. Tungod sa load, na may load ni. Okay? Tungod sa tulo ka force nga nagtabo, mao nang mabali ang beam. Ana, kung di ka gwantang beam, katisting na mo og nisaka mo sa nga nabali. Tungod kay imong weight niya doon na siya support pataas with the reaction. Okay. Kung wala yung reinforcement na niya, balik na dito. Ang katong longitudinal nga atong kuan kaniya sa singly ug doubly, gitawag lang to siya og flexural reinforcement. You need another type of reinforcement which is the shear reinforcement. So, that shear reinforcement is the one that will hold this one para dili mabalik. Okay. Imagine kung na-hold siya ng duha ka vertical nga reinforcement, dili siya mahulog. Okay? Kaya doon naman kayo gitawag na shear reinforcement. So, mao na siya ang mahitabo. So, kung ang beam nimo nga gi-reinforce na nimo og longitudinal reinforcement is still weak, you need reinforcement on the shear. And usually, at the side, there is maximum shear. That's why the spacing here is closer compared at the middle. There is the reason of that. Because at the middle, the shear is practically low. While on the support, the shear force is high, so you need lots of reinforcement. Same goes also to longitudinal reinforcement. The amount of reinforcement is designed according to bending moment. So if you look at the bending moment of this particular beam, bending moment is high in the middle. So this is particularly, you need more reinforcement here. Okay. You know why I add a line? That is additional reinforcement. That means that have more reinforcement, more tension reinforcement compared to the tension reinforcement near the support. What is the reason? In the middle, the bending moment is high. If you look at on the bending moment diagram, the bending moment is high at the midspan. So particularly, you need more reinforcement compared to the reinforcement near the support. Why we need less reinforcement at the support? Na tension magyapon na siya. Tension lagi pero gamay naman ang iyang moment. So practically, you need only maybe two reinforcement. So I will show you the variation of bending moment. Pwede ano yung mo. So pwede anay mo, no? Sa middle butangan nimo og additional nga reinforcing bars. Sa support pwede og duduha lang. Now, the practicality of putting bars at every corner is for the stirrups to install. It's difficult to install a stirrup without a longitudinal bar. Okay. So, I have already instilled in your mind that concrete is weak in tension. Okay, that's one, very important. Number two, you need main reinforcement on the tension side. Okay, number three, it doesn't mean that concrete is strong in compression. You do not need any more reinforcement in the compression. You still need. Second, you need to reinforce the shear, because the beam is addicted to shear and moment, not moment alone, but shear and moment. They are the two of them simultaneously acting, and it depends on your shear and moment diagram where the maximum shear is, where the shear is large. It is up to the moment diagram where the location for the maximum moment or the large moment magnitude. You put more reinforcement for area with more moment and less reinforcement to area with less moment. You put more reinforcement on area where there is more shear compared to the area with less shear. So kung tanawon niyo yung plano, if you have already done your OGT, you will notice that the spacing of the stirrup is not the same. There are areas where the spacing of the stirrups are close to each other. There are also area in the section where there is more reinforcing bars at the bottom compared to the other section, bottom also. There are also areas in the top bar where there are more reinforcement compared to the top bar of the other portion. That's because the shear and moment vary into location. You need to conform your design to the governing, we call that governing shear and moment calculation in your analysis. That's why analysis and design works together. So that's the tool of the designer is the shear and moment diagram. Kung doktor pa mo katong mga X-ray na siya o katong mga reading sa MRI, mga CT scan mo na imong gamiton kung doktor ka, no? So kung engineer ka, you need the shear and moment diagram. You need to know where is the tension kay mao na siya ang kinahanglan og engineer. Your presence is called on the tension side of the beam. Not only beam, but any other reinforced concrete structure. Okay. So, I think ang importante lang karon is that you need to reinforce on the tension side. Okay. So, we will have a break. Okay. If you have some question, just ask it. So, siguro 20 minutes lang, no? Okay? So, I will be excused.